Hello students, this video is for parallelogram proofs. We're in the 9th unit, which deals with polygons. Lesson 6 is dealing with proofs that tell you right away that you're dealing with a parallelogram, which means you have all sorts of different properties that you can use. This diagram is an example of many of those properties, but not all. And this table here shows you a summary of all those properties. It talks about the sides, talks about the angles, and the diagonals. Let's take a look at the learning target here. And in this learning target says, I can apply properties of parallelograms, so you are told that the shapes are parallelograms, to prove that triangles are congruent. So you remember in previous units we did proofs about making triangles congruent or proving that triangles are congruent. Now we're going to be using the facts about parallelograms to try to prove those things. One thing that you should recall is that there are 5 different methods to prove that triangles are congruent. And as a mental exercise, or just to go back into your notes and look back, try to remember what those 5 different methods are. All right, here they are. In order to prove 2 triangles are congruent, you can say that 3 pairs of sides are congruent, or 2 pairs of sides and the included angle are congruent. You can say that 2 pairs of angles and the included side is congruent. You can say that 2 pairs of angles and the non-included side is congruent. Or you can prove that it's a right triangle and say that the hypotenuses are congruent and one of the legs from each triangle is congruent. So those are the 5 different methods to prove that triangles are congruent. What we're going to be doing is saying, well, if you know it's a parallelogram, that's some extra info for you at the beginning of the problem. Let's take a look at the do now. It says the diagram of parallelogram PQRS, and listen to me. As soon as a problem tells you that the shape is a parallelogram, that's a huge boost. As soon as it tells you that it's a parallelogram, that instantly tells you a lot about the shape. Let's try to answer these 3 questions, A, B, and C. Pause the video, try this out, and then come back to see if you got it right. So the first question is, why do you think the shape is called a parallelogram? Parallelograms have opposite sides that are parallel. That's a fact. So PQ is going to be parallel to RS, and PS is going to be parallel to QR. Next, it asks which sides appear to be congruent. Well, you know that PQ is going to be congruent to RS, and you also know that PS and RQ are going to be congruent to each other. And that's just because in a parallelogram, opposite sides are congruent. That's a fact about parallelograms, so as soon as they tell you it's a parallelogram, you know this already. And the last exercise asks us which angles appear to be congruent, and we know that parallelograms have opposite angles that are congruent. So QPS, which is here, and SRQ, which is here, are congruent. And additionally, PQR, which is this one in here, is congruent to RSP, which is in here. Okay, so those are facts that we know already about parallelograms. As soon as they tell us it's a parallelogram, we can instantly get these several facts placed into our proof. Based on the properties of parallelograms, which we summarized just before, and we also saw on the first slide, let's try to write down, and this is something that you're going to put down in your notes, let's try to write down the properties of parallelograms that are going to be used in proofs. And that first one is that in a parallelogram, opposite sides are congruent. Now, you might be thinking, why am I writing it out like this, stating the shape and then stating the fact? This is what you're going to be writing down in your proof, right? For the statement, you're going to say, let's say for argument's sake, this is AB and this is CD. You might say AB is congruent to CD. That's your statement. The reason? Parallelogram, opposite sides are congruent. You have to be kind of explicit about stating what fact about parallelograms you're using. Another fact we know is that in a parallelogram, opposite sides are parallel, so these 2 sides are parallel to each other, so are these sides. Next, we're moving on to facts about angles. So there are actually 2 facts about angles that are pertinent here. We can say that in a parallelogram, opposite angles are congruent, like these 2 angles here are congruent to each other, and these 2 are congruent to each other respectively. And we also say that consecutive angles, which are the angles that are right next to each other here, are supplementary. So for example, this angle here and this angle here are going to add up to 180 degrees. So those are the 2 facts that you're going to need to know about angles in parallelograms that you might be using for proofs. And the last fact that we're going to be using in properties of parallelograms, is that diagonals bisect each other. That point that's in the middle there is the midpoint of both this diagonal and this diagonal. You don't have to state that it's a midpoint when you're writing the proof. You just have to say parallelograms diagonals bisect each other as the reason for a statement that says something like this piece is congruent to this piece. Let's give a couple of examples of what these look like. All right, here's how the first property of parallelograms might look in a proof. The first statement could be that ABCD is a parallelogram if it's given to you. This is parallelogram ABCD. Once you know that it's a parallelogram that it's given to you, the next statement could very well be AD is congruent to BC. AD and BC are congruent. And here's the reason. Parallelogram, opposite sides are congruent. It's literally the sentence that I gave you. So this is what it would look like in a problem. So again, this is an example of how it could look on a problem. If it's given to you that parallelogram EFGH exists, then you can say that HG is parallel to FE. That's just an example of two sides that are parallel. And the reason is parallelogram, opposite sides are parallel. It's the same sentence that we wrote up here. In this example, we have parallelogram JKLM. And if it's told to us that JKLM is a parallelogram, then we're able to use either one of these statements right away. I chose opposite angles are congruent. In this case, JKL, which is this up here, is congruent to LMN. I guess that should be LMJ. Oh, look at that. It is. Anyway, LMJ is congruent to JKL because in a parallelogram, opposite angles are congruent. It's the same exact sentence that we had up here. I didn't use consecutive angles or supplementary, but I could have used that in a proof. And last but not least, here's the final example for a proof. In this example, we have parallelogram PRTU, and those diagonals intersect at point W. If we're told that PRTU is a parallelogram, if that's given to us, then we can say that any of those diagonal pieces are going to be congruent to each other. For example, PW and WT are congruent because in a parallelogram, diagonals bisect each other. This is an example, or these four are examples of what you might see or what you might be able to use in a proof. Now let's take a look at the model problem. The way that we figure out which one of these properties we're going to use is by looking at the model problem, figuring out what needs to be proved, and then trying to use an appropriate characteristic of parallelograms. So in the model problem, it tells us that parallelogram ABCD is shown at right, so we instantly know opposite angles are congruent, opposite sides are congruent, opposite sides are parallel, opposite diagonals are going to be diagonals are going to be bisecting each other. So we're not going to give all that information. Let's be selective. Let's pick only the information that's going to help us here. We have to prove that DAX is congruent to BCY. So let's first label the diagram with what we know. So we know that DX is congruent to BY. That means this line and this line, respectively, are congruent to each other. And since it's a parallelogram, we know something else that's connected to these two triangles. We actually know two other things that are connected to these two triangles. We know that this angle, which is angle ADX, is opposite of this angle, which is angle CBY. And it turns out that those two are opposite angles in the parallelogram, but they're also angles within the triangles. And similarly, we know that line segment BC is an opposite side to line segment AD. So they're opposite sides in the parallelogram, but they're also related sides in the triangles. So I've chosen two different pieces of information to use in my proof. Let's try to write out what the proof would look like. Keeping in mind that the method that we're going to try to use to prove that these two triangles are congruent is going to be based on the stuff that we know. So I guess before we even start writing the proof, let's plan out what the method is that we're going to be using. We know that this side is congruent to this side. We have a pair of congruent angles that's included, and another side that's congruent to another side. Looks to me like we're going to be using SAS in our proof. Okay, now that we have a plan, now that we know that there are some things in the parallelogram that need proving, let's now start writing out the proof. All right, so far it's been pretty standard, pretty straightforward. It says that parallelogram ABCD is shown at right, so I'm going to write parallelogram ABCD, which is given to us. It also tells us that DX is congruent to BY, which is here in the givens, and of course we write given. The next thing that I wanted to prove is that this angle is congruent to this angle, and if we look back to our reference, we're able to see that opposite angles are congruent. That's the reason that we're going to use. So here's how it looks. And now I put down the statement that ADX is congruent to CBY, and I'm using as a reason parallelograms tell us that opposite angles are congruent. Now keep in mind, I would not be able to use this statement, this reason, parallelogram, unless I had somewhere else in my proof said that it's a parallelogram, right? This is keyed into the fact that, well, since I know it's a parallelogram, then opposite sides are congruent, opposite angles are congruent. Now let's deal with the sides. That's BC and AD. So now I've got a lot of my information that I need written down. I know that these two sides are congruent to each other because it's a parallelogram and opposite sides are congruent. These two angles are congruent because in a parallelogram, opposite angles are congruent. And these two sides are congruent because they told us at the beginning of the problem. I have SAS now, so I'm comfortable with writing my fifth and final statement. I have to prove that DAX is congruent to BCY. So let's write that out now. There we have it. The fifth and final statement is DAX is congruent to BCY, those two triangles, because of SAS postulate. I want you to think back to what we did in the unit we dealt with triangle proofs. This is not any different than triangle proofs. This is just another source of information or another source of reasons in order to prove that the triangles are congruent. This is actually making it slightly easier. All right, moving on to the third part. In this partner practice, we do want you to try to do this by yourselves in class. So we're not going to go over that. And same thing with the check for understanding. So it looks like we have reached the end of the video, the problems that we're going to be doing in class as well. As is customary, I typically give some small hints. So in this case, it gives you a lot of information. And it tells you that these lines, BF and AC and DE and AC, are perpendicular, which means you got right angles here somewhere. So my suggestion to you is, if you have right angles, it's going to be a right triangle. And if it's a right triangle, there's a specific type of proof that you're going to be using in order to prove that the triangles are congruent. That's my little hint for you there. And for the check for understanding, again, it gives you perpendicular sides. So you may or may not be using that same method to prove that these two triangles are congruent. Last but not least, the last piece of advice I'll give you is that it does ask you for two pieces of the triangles that are eventually going to be proven congruent. Remember that in order to prove these pieces are congruent, you're going to use that acronym CPCTC. That's enough hints for you there. All right, that was the lesson on parallelogram proofs. Not a different procedure, just more information that can help you prove that two triangles are congruent if you know that the shape is a parallelogram. All right, folks, good luck studying.